The next problem that we're trying to solve is ones and zeros too. In this problem, we are given a binary string s. Okay, and we are supposed to find the max value of f of s. We are supposed to find the max value of f of s. F of s is a function which tells us to find the number of good prefixes of the string s. Now, what is a good prefix? A good prefix is nothing but if there is a given string, let's say 1 0 0 1 0 1. Okay, this is a string given to us. A good prefix is something in which the number of ones is greater than or equal to the number of zeros. The number of ones is greater than or equal to the number of zeros. That is what a good prefix is. Now the question says we need to find number of good prefixes from the given string s. Now they are also giving us an operation that we can perform. The operation is we can swap adjacent digits or adjacent characters present inside the string. Okay, so the final ask is that we need to find the max possible value of f of s by using minimum adjacent swaps. Okay, now what is the meaning of max possible value of f of s? Max possible value is nothing but after making minimum adjacent swaps, the string that we get, in that string, the prefix, the number of prefixes, number of good prefixes, where number of ones is greater than or equal to number of zeros should be maximum. Okay, let's take some examples and then try to understand what the question is and how we should solve this problem. Okay, let's take an example where if given string is 1 1 1 and 1. Okay, it has only 4 characters, all ones. In this, if we take a prefix of only containing a single 1, then it has number of ones greater than number of zeros. If I take first 2 characters, then also number of ones is greater than number of zeros. If I take first 3 characters, then also number of ones is greater than number of zeros. If I take all 4 characters, even then number of ones is greater than or equal to number of zeros. So here we don't need any swaps. So in 0 swaps, we are getting a string in which f of s value is equal to 4. Right? The prefix length is 4, in which number of ones is greater than or equal to number of zeros. Right? And 4 is our maximum possible value of f of s. Right? Let's look at another example. Let's say I have 1 0 0 1. Okay, in this we have 2 ones and 2 zeros. We want to figure out what can be the maximum value of f of s, what can be the maximum value of f of s in minimum swaps. Alright, so here if we see whatever prefix we choose, either this prefix or this prefix, whatever prefix we choose, the goal is that the number of ones should be greater than or equal to the number of zeros. And if I choose the first 3 elements or first 3 digits, then definitely number of ones is not greater than number of zeros. But they have already told us that we can perform swaps in order to change the position of ones and zeros. Right? We can only perform adjacent swaps. Like it means adjacent elements can only get swapped. We cannot swap any random elements. Okay. So here if we want to perform that, what we can do here is this one, the last one that is present at the end, can be swapped with the previous 0, and we can get 1 0 1 0 as a string. And in this, if you see if I take the entire string as the prefix, then I'll get f of s value as 4 and one swap is performed. So answer over here is 4 is the maximum value of f of s, and with one swap we were able to achieve it. Okay, let's look at one more example. Let's say I have 1 0 0 0 1. Right, if I have to find out the max value of f of s in this particular string, right, then I'll have to start from the beginning and see what can be the max possible good prefix. Okay, what would be the length of the max possible good prefix? Now here, in a prefix is considered as good if it has greater, or let's say number of ones in that prefix is more than or equal to number of zeros. Okay, so here if we count the number of ones, we have 2 ones and we have 3 zeros, right? So if I want to get the biggest prefix with number of ones greater than or equal to number of zeros, then it would be of length 4. Why it would be of length 4? Because if you see, if there are only 2 ones, right, then there can only be 2 zeros in my prefix, not more than that. There can only be 2 zeros in my prefix, so that I get 1 1 0 0 followed by an extra 0, so that I have equal number of ones and equal number of zeros in my prefix. Okay, now I cannot have a bigger good prefix than this. Okay, all right. So if I take a different example, let's say I have 1 0 0 1 0 1 0 0 0 and then 1. Okay, here let's say how many zeros and ones are here, ones are present. 1 2 3 4. We have 4 ones and we have 6 zeros. In this we have more ones as compared to zeros, and clearly if I want to have the biggest good prefix, then the biggest good prefix can be found by placing all ones together and then placing all zeros together followed by 2 zeros. So biggest good prefix will be of length 8. Okay, it's not mandatory to be this way. We can even have 1 0 1 0 1 0 1 0 and still we can get a biggest prefix of length 8 followed by 2 zeros extra. Even this is valid. Okay, so this is giving us a hint that based on the number of ones we can actually decide what will be the length of my biggest prefix. Now you might have seen in the question that they are not asking us biggest prefix, they are asking us number of good prefixes. Number of good prefixes. All right, now why am I telling biggest prefix every single time when they have asked us to find number of good prefixes? Is if you take a look at this example, right, over here, if I only take the first one, I have 1 1 and 0 zeros, right? Number of ones is more than number of zeros. If I take the first 2 elements, then I'll have 1 1 and 1 0. You have equal number of ones and equal number of zeros. If I take the first 3 elements, then I'll find 2 ones and 1 0, right? Here we have more ones than zeros. If I take the first 4 elements, then I have 2 ones and 2 zeros, right? So here I have equal number of ones and equal number of zeros. So what is happening over here is the prefix that we are taking, in order for that prefix to be good, we need to have equal number of, not equal, number of ones should be greater than or equal to number of zeros. Okay, now here if we see how many prefixes do we have, If I take single element, that is one prefix. If I take the first two elements, that is second prefix. If I take the first three elements, that's the third prefix. If I take the first four elements, the fourth prefix. If I take the first five elements, it is fifth prefix. Like that, if I keep going, I have total 8 prefixes over here. Right? So instead of finding individual prefixes, what we are trying to do is, we are trying to find the largest good prefix. We're trying to find the largest good prefix length, because if we find the largest good prefix length, then all the smaller sub prefixes will anyhow be good. Okay. So with that thing in mind, we are trying to find the largest good prefix so that all the smaller good prefix will anyhow be good and will indirectly count all the prefixes. Okay, so we simply are trying to find the length of the largest good prefix. Okay, so I hope this is making sense. We'll move forward towards the approach right now. Okay, now what is the let's say we are given a string, and let's see what we can do in order to find out the largest good prefix. Let's say we have 1 0 0 0 0 1. Let's say this is our string given to us. Okay, initially we have a 1. Okay, now this 1 is followed with a 0, right? Whenever a 1 is followed by a 0, we can say that this 0 balances this 1. 0 balances 1. Okay, whenever we have zeros which are not balancing any 1, whenever we have zeros which are not balancing any 1, we'll call them as extra zeros. Okay, whenever we have zeros which are not balancing any ones, we'll call them extra zeros, or we can also call them as unbalanced zeros. Alright. Similarly, if we have a string like 1 1 1 1 0. Okay, so here we have a 1, 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 right? These are not balanced by anybody till right now. If I only consider the first 4 elements, they are not balanced by anybody, right? But as soon as I consider a 0, as soon as I consider this 0 will balance out one of the ones, right? If it balances one of the ones, then I'm left with 3 extra ones. Alright, cool. Moving forward, now let's take one more example where I have a string in this string. I have first one, which is an extra one. I have a second one, which is also an extra one. The moment I get a 0, this 0 balances out this 1 and number of extra ones reduces. The moment I get a 0, this 0 balances out this 1 and number of extra ones reduces. Now we do not have any extra ones. If I get a 0 again, this becomes an extra 0. Okay. If I get a 0 again this becomes an extra 0. This 0 again extra 0. This 0 again an extra 0. But this one over here is used to balance out these extra zeros or unbalanced zeros, right? How will we balance? We will have to use swap operations. This one can be swapped with this guy. Again it can be swapped with this guy. Again it can be swapped with this guy. And again it can be swapped with this guy. So 4 swap operations are needed to move this one to this position. And when we move it, then automatically 1 extra 0 will get balanced. How? Like this. We'll have 1 1 0 0. After that we have a 1 over here, 0, 0, 0, 0, 1. So this 1 balances out this 0, right? And that's how we are performing this balancing operation. Okay. How many swaps did we perform here? The number of swaps is equivalent to the number of extra zeros that we were having. The number of swaps is equivalent to the number of extra zeros that we were having. Okay, cool. So now let's take a bigger example and then try to understand step by step how we will calculate the swaps required and how we will find out the longest good prefix. Okay, let's say I have 1 0 0 0 0 0 0 1 1 0 1 1. Here if we see, we have 1 2 3 4 5 ones and more zeros, 1 2 3 4 5 6 7 zeros. While looking at this, we can say that the biggest good prefix will be of size 10. Why 10? Because we have 5 ones and 5 ones can be balanced out with 5 zeros. So 5 ones plus 5 zeros will be equal to of length 10. Okay, 2 zeros are extra over here. 2 zeros are extra which we will not be using in our good prefix. Okay, so but now how do we figure out the number of swaps needed? That is what we need to understand. In order to understand or figure out the number of swaps, we will actually maintain some data. Okay, let me write down that data. Firstly, we'll maintain how many swaps we have performed already, mean swaps. Initially we have not performed anything, so swaps is 0. Then we'll maintain something called as unbalanced zeros. Initially we have not processed the string, so unbalanced zeros is also 0. Extra ones, how many extra ones do we have? Currently we haven't even gone through the string, so extra ones is also 0. And one more is current good prefix length. Even this value will be 0 because initially we don't know what is the good prefix length. Okay, cool. Let's start iterating the string. Let me give indices 0 1 2 3 4 5 6 7 8 9 10 and 11. We are at index 0 right now. At index 0 we have a value of 1. This 1 cannot balance any 0 because number of unbalanced zeros are 0. It means this 1 is an extra 1. Okay, so we'll add it as an extra 1, and as we can have more ones as compared to zeros, this can be considered as a good prefix. So we will consider a good prefix length of 1. Okay. Moving forward, at index 1 we have a 0. Whenever we get a 0, we'll see, do we have a 1 that this 0 can balance? Extra ones are there? Yes, it's there. It means this 0 will remove that extra 1, or you can say will balance this extra 1, and current good prefix length gets incremented. Now we have a prefix length of 2, a good prefix length of 2. Move forward, we are at index 2. At index 2 we have a 0. Can the 0 balance out an extra 1? No, extra ones are not there. So we'll simply remember that one unbalanced 0 is there with us. We'll move forward. At index 3 we have a 0. Again this is an unbalanced 0. So unbalanced 0 count increases. Then at index 4 we have a 0. This is also unbalanced. So again this count becomes 3. At index 5 also 0, count became 4. At index 6 also 0, count became 5. So we have 5 unbalanced zeros. we have 5 unbalanced zeros. Moving forward, we are at index 7 right now. At index 7, we have a 1. Now, this one can actually balance out unbalanced zeros. How many zeros do we have? 5 zeros. So, 1 1 can actually balance 1 0. Okay. But before balancing, let's swap it and move it to its appropriate position. Now, we don't need to perform that swap actually, but we need to remember how many swaps need to be performed. Okay, so we are at this index 7. So from here, we'll swap with 6, with 5, with 4, with 3, with 2. So total 5 swap operations are needed. So 5 gets added to the number of swaps performed. Now, along with that, current good prefix length will also get incremented because uh, we have got a 1, right? After 1 and a 0, we got a 1, which is valid, right? 1 will be placed over here after swapping. That's why good prefix length increased by 1. Extra ones also got increased by 1. Okay, we have increased the number of extra ones because now if we only consider the first 3 elements, then we have 2 ones and only 1 0. Okay. Now, after the swap, this is what we are having as our string. This will be 0, this will be 1. Okay. So minimum number of swaps performed is 5 right now. Extra ones is 1. Good prefix length became 3. Okay. Now, the moment this swap is performed, after that we check. Do we have unbalanced zeros? Yes, 5 unbalanced zeros are there. So this one that got swapped, it actually balanced 1 0. So we'll reduce the number of unbalanced zeros to 4. Okay. And because this unbalanced 0 was balanced, extra ones are reduced. We do not have an extra 1 right now. Why? Because it has balanced this 0 right over here at index 3. Okay. And because of this balancing, the current good prefix length has also been increased. It's been increased to 4 right now. Okay. Why 4? 4 because of this first 4 elements. 1 0 1 0. Okay. Moving forward. The next element in our sequence is at index 8. At index 8 we have a 1. The moment we get a 1, we'll see, do we have unbalanced zeros or not? Of course, we have unbalanced zeros. So, we'll see how many swaps are needed to move it to the appropriate position. Now, in order to move it to the appropriate position, this guy should move to index 4 right now. In order to move to index 4, how many swaps are needed? 1 swap, 2 swaps, 3 swaps, and 4 swaps. So 4 swaps are needed for element at index 8 to reach index 4. So swaps get incremented, swaps becomes 9, and 1 extra 1 has added. Current good length prefix will also get incremented by 1. Okay. After this, we check. Do we have unbalanced zeros or not? Of course we have. We do have unbalanced zeros. So let me just make the change. We do have unbalanced zeros. We have 4 unbalanced zeros. Out of all those 4, 1 0 is getting balanced right now. So balancing that becomes 3. Unbalanced zeros are 3. Extra ones will get nullified, it becomes 0. And because an unbalanced 0 is balanced right now, current good prefix length will become 6. Okay. Moving forward. What is the next element in our sequence? Next element in our sequence is at index 9, which is 0. As 0 cannot balance an extra 1 because there is no extra 1. So we'll simply keep incrementing the unbalanced zeros. There are 4 unbalanced zeros right now. Okay. Moving forward, at index 10, we have a 1. Now this 1 needs to be moved somewhere. But where to move? This 1 will be moving to index 6. Why will it be moving to index 6? Because already the index 0 to 5 part is balanced. right? So the only place where it should move is at index 6. So let's move it to index 6. We need 4 more swaps to move it to index 6. After performing 4 swaps, minimum swaps becomes 13. Number of extra ones becomes 1. Good prefix length becomes 7. Now, the one that we have moved, the one that we have swapped, will actually balance an unbalanced 0, right? This 0 over here will get balanced out. It means number of unbalanced zeros becomes 3. Extra ones will not be there, it becomes 0. Prefix length will get incremented by 8. Okay, cool. Moving forward. We are currently right now at index 11. The value is 1. If the value is 1, it needs to be swapped. It needs to be swapped with index 7. No, not with index 7, with index 8. Why with index 8? Because already from index 0 to index 7, the string is already balanced. It's a good prefix already. Okay. So in order to do this swap operation, we need 3 swaps. 11 will swap with 10 first. 10 will swap with 9. 9 will swap with 8. So 3 swaps are needed. So we'll add 3 to our minimum swaps. Minimum swaps becomes 16. Extra ones becomes 1. Current good length becomes 9. Alright. Now after this swap operation, our string looks something like this. This one is 0 and this one is 1. Now we have 3 unbalanced zeros. Out of these 3, 1 0 get balanced. So unbalanced zeros becomes 2. Extra ones will get reduced. Current prefix length will become 10. Okay. Once we have done this, we do not have any more characters to look out for, right? So we'll stop here, and the value present in current good prefix length will be the biggest good prefix that we can actually find, and that will be our answer for the biggest good prefix length. We also need to find one more thing, which is number of swaps. The variable minimum swaps is actually counting the minimum number of swaps needed to actually achieve this prefix. So our answer at the end becomes 10 and 16. Okay. This is how we solve this problem.